see what we're doing here. So many people get their water from water utilities, some from a private well. Is anybody rainwater harvest? So I'm Claire. Nice to meet you all. I'm going to start by backing up a little bit and talking about the geology of our basin and our region. It's called the basin and range, and it basically is normal faulted bedrock that has been filled in with a lot of sand and silt off of the mountains to fill up these big basins. So when you look across from one mountain range to the next, you're looking across a very deep level of alluvium. Over time, the water goes into that ground, goes across the surface, goes into the ground, and goes and fills up that alluvium. So it fills up between all the little sand particles. And that's where we get our groundwater. So it's important to understand that your groundwater, the amount of groundwater you have, is really dependent on the amount of alluvium in that basin. So if you have mountains very close together, or if you're right up against the mountains, you have less alluvium, you have less groundwater. So that's the basic concept behind groundwater. So when we think about it, and I'm sorry these are a little fuzzy, they're against the wall, that's one downside.
Sorry.
And it's actually kind of hard for us to look at them too. But you can see that there's the thing I just was talking about, the fact that you have pore spaces and you have the water right between those pore spaces and you're pulling it up out of that area. So this is just an example where you have a well, a house, a well, the groundwater goes into it, it gets pulled out of those pore spaces and it goes on up into the house. This area is an unsaturated zone, so there's almost always, unless you're in a creek, an area of that alluvium where there's no water. You have to get below that, and this surface is called the water table. So when you talk about the water table, you're not talking about a table underground. You're talking about the top of the saturated zone beneath the surface. So when you put a well in, this is what happens. Imagine that funnel shape over there is actually the surface of the water table. Put the well in, you draw water out, you actually create a cone of depression. That means that if you have a nearby well, you could affect that nearby well. If you have your well right here, but there's another well over here, then this one will actually feel the effects of the first one. So they interact underground. How they interact is very dependent on the geology, on the actual way the alluvium was laid down. So if you're connected through a gravel that pulls water very quickly through it, then you might feel the effects more quickly or more drastically than if you have silts. So it's all about that. So looking at Tucson, at water in the Tucson AMA, it's easier to find information about active management areas because they actually have collected that information statewide. So outside of AMAs or in areas without a water utility looking at the whole area, then it can be more challenging. In the Tucson AMA, this is the situation. I'm gonna take your attention to this right here. And this is sustainable groundwater. This is renewable groundwater, all of this. So sustainable groundwater would be the amount of water that you can pull out and actually it is recharged by the surface water. So it's no more than would be recharged. So in this case, as we grow, the demand grows up here. This is the demand curve. And here in the Tucson area, this is up in Tucson, there's cap delivery, which actually is supplanting it. There's still the sustainable groundwater being pumped out on top of that, laying on top of that. This is water reuse, so that's reclaimed water. So you can kind of think of it as a mountain of water that we're using. Now, if we didn't have cap delivery, all of this would be mined water, right? That whole thing would be mined water. Here's the demand, and here is where it's actually gone below that sustainable water bit here. if you just follow that up. That's where we hit safe yield. I think he actually put this on there. That's where you hit safe yield, and we are in safe yield in the Tucson AMA. So you can see here over on the side, other sources are effluent reuse, so treated wastewater and CAP water, Central Arizona Project water from the Colorado River. And if we don't meet the demand, we pump more groundwater. That's what happens. So we were talking about the top of the water is the water table. And in this case, the top of the water table in your region is quite deep underground. It varies. But like if you go up in the edge of the mountains, you'll see it intersecting the surface when you have springs. But more water is being pumped than can be naturally recharged. And that means we're mining water. So whereas the Tucson AMA might be in safe yield, here there are a lot of places where we're mining the water. That creates a situation which we call overdraft, where we're overdrafting the supply. There's a lot of water. There's a lot of water in the AMA at 60 million acre feet above the 1,200 feet level. But as we pump from deeper, and you can pump more deep water, you just have to be aware that the water quality goes down, and also it costs more to pump that water. So there's a number of things that make it not very good to pump more water than you need. So this is a diagram to help you see that. We have this is sort of just a general diagram, caricature. Atmospheric moisture comes in, have condensation, it falls in rain on the mountains, and it goes into the river goes down into the bottom, there's a mound in that water table here, and it recharges. Groundwater flow is going into the picture here, so it's going down the river. We take it out for municipalities, we take it out for agriculture, and sometimes there's plumes. There are contamination plumes. In this case, this is a sulfate plume from the mine, and that can be up here in this unsaturated zone, but it can also get into the saturated zone, and then it can be moved along in the groundwater, so it can be brought along. There are a lot of wells in the Green Valley and Sahuarita area. This is just a map of all the wells. Lots of wells.
Oh my goodness.
Yeah. And you should see Phoenix. There's way more. Now the majority of these wells are something that we call exempt. And I'm going to explain to you the difference between an exempt well and a non-exempt well. So these are non-exempt wells. They're public utility wells. They're water provider wells. They generally pump more than 35 gallons per minute, and they have to report all their water usage to our water statewide agency called the Arizona Department of Water Resources, who looks at the water. They look at the water resources all over the state. And then we have something called exempt wells. These are exempt from reporting. That's why they're called exempt wells. They're generally less than 35 gallons per minute. They have a 10 acre feet per year. Actually, that's not correct. It should be 1 production limit, and there's no reporting requirement. So here's a bit of an idea about what's happening in your area. These are index wells. These are ADWR index wells, and they have a few of these wells all over the state so that they can get these long track records. And you can see, in general, you can match the color. Here's the orange one. It's going generally down. There was a uptick right here, and then generally down, and generally down. They're all going down except for this one, and this is startup of cap recharge, and that is, I believe, this one right up here. So you can see the effects of the recharge of the cap water. So you are moving downhill. So what does overpumping really do? Because you've probably heard about subsidence. Have you all heard about that? So what's actually happening when you have subsidence is air is replacing the water. You pull down the water, and then air replaces the water. And then you get compaction of the sediments, particularly in silts, and not quite as much in the sandstone aquifer portions, but in the silts and the clay layers. Those squish up, And then it's harder to get through. And some compaction in this area here. Usually compaction is not reversible. Now this is very, again, dependent on the geology, because if you have a gravel and it's held by quartz crystal or quartz bits, yes, gravel bits, holding that area apart, then you may not get as much compaction as another area. That's why it varies, and it just really depends. Some areas are much more prone to compaction and subsidence. So the last thing I'm going to talk about in this section is shallow groundwater areas. And the reason I'm going to talk about them is because this is where your groundwater hits the within 50 feet of the surface. This was a study done by PEMA Association of Governments several years ago, so the data is a bit older, but that's where a tree might actually have a root all the way into the groundwater. That doesn't necessarily mean it's above surface, but it does mean that it's affecting the riparian areas, and those are really critical to our natural habitat. Almost, I think it's like 70% of invertebrates, or I don't know if it's all animals, but invertebrates anyway, rely on riparian areas and water in Arizona. So these are really important areas. And I'm just pointing these out. The Madera Canyon's up here, the Santa Cruz River through here, Soapary Wash through here. I think this is Arivaca over here. These are all areas, and you'll see, notice there's a lot of wells in those areas. People have a lot of private wells in those areas because they can reach the water, and there's historical water there. And one of the problems with that, of course, is that you have a sensitive area, and as it gets hotter and drier, people are using that water, and they're more prone to have groundwater decline. So now, who do you think uses the most water in Green Valley and the Sahuarita area? People, mines, or pecans?
Mines or pecans? Let's see. Well, it's one of those. These are the main water users in the region. Mines, water providers, that's people, agriculture, and private wells, also people. Mines use a great deal of water.
Yes.
Approximately 15,000 acre-feet is used by ASARCO in the Mission Complex. And I won't go through this, but you can see that they get their water from various places. Not all of it is groundwater. A lot of it comes from the CAP, from the Tohono O'odham. And they use it to make copper, obviously. So, that's a great picture, don't you think?
Yeah. Wonderful.
Yes. Not too fast.
Yeah, let's go see.
And Freeport, another large mine in the area, also uses a great deal of water. But the water it uses these days is the water it's using to remediate the sulfate plume. So it's not using drinking water now. It's using water that would not, that they are voluntarily pumping out of the ground, treating and putting back, and using instead of other groundwater. Now, do we remember how much water the mines were using?
15.
So, in other words, the mines win. The pecans use a lot of water, 25,000 acre-feet of groundwater per year, and they're using groundwater. Unlike the mines, that all of that is coming out of the ground. So you could say that pecans use the most groundwater. But they are working to get CAP water, which they're going to store underground and receive credit for storing underground. There's another great picture. Oh, I want to stop for a moment to thank our wonderful graduate students who found these beautiful pictures and who did a huge amount of work on this project, and we wouldn't have been able to do it without them. Here are the water providers, and you can see them spread out from here and to here. These are the water providers, and this shows the service area of the water providers in the area. So you could pick out who serves you water. But as you can see, they serve about 9,400 acre feet of water per year, which is regulated. They have to report how much they take out, and they are regulated by the Department of Water Resources and how much water they can pump, and they are also regulated by the Department of Environmental Quality on the safety and quality of the water that they serve. Private exempt wells that Claire talked about, as you can see, there are a great many of them. And as she said, they pump maybe a 1 acre foot per year, and then multiply that by the about 480 exempt wells that are in the area, and that's about how much water is used by private wells in the area. It's not a huge amount, but it can be significant in certain areas where they're pulling down surface water from the environment. So here's the general picture. Here's the story of Green Valley, Sahuarita area's water use. You can see that the mines use a great deal, agriculture here, at more water providers, and then a little bit for golf courses and sand and gravel operators, and exempt wells, a little bit for exempt wells. This is how much groundwater there is. So all of this is pumped in excess of renewable groundwater. There you are, there's the overdrive. And it's about 35,000 acre feet per year. So, we're going to move on to water quality, and Claire is going to talk about that.
Well, let's talk about water quality a little bit. So let's start with groundwater quality, because you're probably aware that your water providers have to test and ensure that you're getting good quality water. And somebody mentioned the pipes. That's always a concern, particularly if you have your own pipes in your house, which are very old and maybe lead pipes. So you have to look at that kind of thing. But there are also 480 groundwater wells, exempt wells, which actually can feed more than one home. So, you know, it could be more than that. Oh, I see, it just went right past. So this is a map. On this map, the colors of the dots, all they mean is who sampled them. So don't worry about that. There is natural arsenic. Every one of these dots is an area where there's been some sort of exceedance. That doesn't mean it's an exceedance, or some kind of, sorry, not an exceedance, some sort of sample where they found it. It doesn't mean it's an exceedance. And the water providers do treat the water. The things here listed on this list are arsenic, tritium, dissolved solids, one or more pesticide compounds, one or more volatile organic compounds, and nitrates, which come from agriculture. So those are all things that could be in your water, in your groundwater. If you are in a groundwater well, it's really important to test your water. So where does water pollution come from? And there are a lot of historic sources that may not currently be sources, but once it's in the groundwater, it's in the groundwater. So landfills and wildcat dumps and spills. This is a picture of a wildcat dump. underground storage tanks. Those are the tanks at gas stations where they used to have them all underground, you know, and you go up and it seemed all clean and nice and you didn't know it was dripping into the ground. Wastewater treatment plants, not always, but sometimes. Wastewater treatment plants used to be a real problem, but they're no longer a problem. In fact, haven't been for many years. So they are a historic concern. And then industrial sites, mines, airports, fire training centers. These are often a problem because they have fire suppressants. So they have a history of using like TCE and other things that actually they spray to suppress fires, or to dry cleaning is also another potential contaminant source because of the chemicals. A lot of the dry cleaning is not, I think it's a lot better now, but it used to be basically treating your clothes with chemicals, and those chemicals were often disposed of on site, or there were leaks in tanks, and so that's why there are different contamination areas. Your area is actually very good. We'll look at that. There's not a lot happening. You can find out a lot of information from the Arizona Department of Environmental Quality, and here's a website. We will post all this information so you'll be able to go back and look at this in the future. They have a lot of maps, they have a lot of data, but it can be a little challenging to get through it and figure out what's important and what's not important. That's always a challenge with technical data. So underground storage tanks, including car service stations, mine sites, golf courses, and they might have petroleum products or chemicals, various different kinds of chemicals. These are all sites over here. I'm going to blow up that map now so you can see. Those are all sites where there were underground storage tanks, either were or are underground storage tanks. So the green are the open sites, and the orange, if I go back, let's see, the open sites are green, temporary are blue, closed, can't even read that. Yellow. So.
And that's orange?
Removed is orange.
Yeah.
Which?
Removed.
Oh.
So you just have a few that are open now. It's actually the older ones that are more of a concern because they do a lot more testing now. So, oh, did I read that? There are no suspected or confirmed releases from underground storage tanks. So it's really more something to be aware of. Landfills, you had a landfill, I put a big circle around it there. It became a transfer station in 2015. You could get petroleum products, heavy metals, solvents, but there's no confirmed releases or suspected from Sahuarita landfill. It was lined a long time ago. There actually used to be a landfill on the other side of the freeway, on the east side, and I'm not sure if there's contamination from that, but at one point there was a landfill over there as well. Okay, voluntary remediation sites. So under ADQ's regulations, they allow some voluntary remediation. So when you hear this, if you hear this term, what it really means is that they have decided to go ahead and invest. The industries that have some culpability have decided to invest in remediating the site. And as a result, they get a break from ADQ. They won't do enforcement actions because they're working on it, and the site is closed once all the objectives have been achieved. So there are these sites out there, and these are the two in your area, and those are both under remediation. Wastewater reclamation. This is the Green Valley reclamation site, and it's been great. You should just be very happy and proud about it. It's in good shape, and they do a good job out there. So it gets top ratings. It reclaims or treats 4.1 million gallons a day, and it serves 23,000 people. And it is used for irrigation, infiltration basins, and industrial uses.
Where is that located?
Oh, I don't think we have a map. It's
That's from Quail Creek.
yeah,
Yeah.
most of it actually goes out to Quail Creek. They have and Pima County runs the facility, I believe. And it goes, and most of that goes out to Quail Creek for the golf courses. I think they were negotiating some change to that at some point, but I'm not sure where that stands right now.
It's across from the Veterans, it's right next to and north of the Veterans Dog Park.
Oh.
You can go back in there.
So sulfate plume, how many of you came in here thinking, I wanna know about that sulfate?
Never heard.
Yeah, I know, it's been a hot button issue in Green Valley for a very long time, and a concern as well. It should be something that you know about and think about, but I'm here to also tell you some of the science behind it, that you're okay and they're doing some good things. And so here it is. Why is there a sulfate plume? It's because the pipelines leaked, and there were overflows, and it went into the groundwater. So it's not that they're dumping the water, tainted water into the ground. It's that there were leaks in the system.
It's a mine pipeline?
It's a mine
Okay.
pipeline. Yeah. They use an oxide and low-grade sulfide stockpile leaching system. And most of it is captured and recycled. Most of it is captured and recycled. And here's the plume. So I'm going to show you quite a few slides about the plume so you get a feeling for and talk about the actual chemistry. So what is sulfate? You can see the chemical formula over there, and it's not sulfuric acid. So some people confuse that. Oh my God, there's sulfate. It's got to be like sulfuric acid. It's not. It is regulated to taste at 250 milligrams per liter, and above 500 milligrams per liter, it's purported to have a laxative effect. Don't know if you want to import this water or anything, but concentrations below 500 milligrams per liter haven't got health issues. So that's really good. It has undergone. Because it's undergone this chemical change from sulfuric acid into sulfate, it's no longer hazardous. It's no longer regulated as a hazardous material, and it's no longer hazardous in these concentrations. So when you look at it, what happened is, what they're doing is they have this pump and treat system where they're pumping and treating it, and they're pumping it out of the aquifer and then using it in the mines operations. You might recall Susanna mentioned that much of their water is from this. And the well field is designed, over there on the left, to actually limit the spread. So it's not just pulling it out willy-nilly, it's actually around it so that it will capture it before it leaves the site or migrates. And these are modeling results expected into 2100, okay? So the plume is here in the yellow, and every plume is the next modeling result. And you can see it gets smaller and smaller and smaller because of their remediation. That's their expectation, that's what they're working towards. And you can see the tailings are here, the brown, and the yellow, the green is the property boundary. So you can see right now it goes outside the property boundary, but eventually, hopefully it won't. I guess it still does a little bit over there on the right. So it's nice to know they're doing that modeling, huh? They are concerned about it. All right, now we're going to move into the future.